Hi, pre-calc. Here is your video for our start of our non-right triangle trig unit. So we'll talk a little bit about the law of sines and the law of cosines. And I want to make sure that we're all on the same page with a few things. So for this lesson, we're investigating sort of the law of sines and what we do when we have something that's not a right triangle. So what we're going to do right now is I just want to make sure that we're all on the same page about labeling triangles, which may sound silly, but it will help with some confusion as we're sort of creating these equations. So it's important to know that typically we'll label a triangle as A, B, and C, and angle letters are always capital letters. So A, B, and C as capital letters, and side lengths are always lowercase letters. And the side lengths are always directly across from their angle label. So lowercase a is directly across from angle measure capital A. Side lowercase b is directly across from angle, sort of big B. And side lowercase c is always directly across from our angle C. So the next thing that this says is to look up what an altitude is when talking about a triangle. So an altitude of a triangle is perpendicular It's a perpendicular line from the vertex to the opposite side. So from a vertex to an opposite side. So draw an altitude, the triangle above from vertex B. So if I were to say that I have the same triangle as above, where here I have B, this was A, and this was C. This is little a, little b, and little c. If I wanted to draw in an altitude, I would drop straight down, and this would create a 90-degree angle. So these lengths won't necessarily be equidistant, but I do know that I've created a right triangle there, and that's something that we know when we talk about our trigonometry here. We're talking a lot about these right angles. So when we don't have a right angle in a triangle, we can sort of create one. So we're just going to walk through this investigation together. It says, with our background knowledge of right triangles, and now that we've covered the first page of this packet, we're ready to move forward and dive into today's topic, investigating what happens when we want to solve a triangle that isn't a right triangle. So here we have the triangle ABC that's shown on the right, which is nice and appropriately labeled. This is asking to sketch an altitude from vertex B. So here I will come and sketch my altitude from B, and there it is. And we will label that altitude K. It says the altitude creates two right triangles inside of ABC. So notice that angle A is contained in one of the triangles and angle C is contained in the other. So here is one of my right triangles, and here is my other right triangle. So, using right triangle trig, write two equations, one involving sine of A and one involving sine of C. So here is this angle A, so sine of A is going to be opposite over hypotenuse, so K over C, and sine of C, which is right here, is going to be K over A. So it says, number 4, notice that each of the equations in 3 involves K. Why does this happen? So we can say that it happens. We can see here that it's happening because K is the opposite side for angle A and angle C. Now I have solved each equation for K. So if I solve this equation right here, I'll end up getting that C times sine of A is equal to K. And if I solve this here, I'll end up getting that A times sine of C is equal to K. Since both of these equations are equal to k, then we can set them equal to each other. So c times sine of a equals a times sine of c. So if we notice, this equation here that I've created no longer includes k. And remember, k was the altitude that we had created. So we sort of used our right triangle, and now we sort of backed out of having that altitude, or sort of made up altitude in our equation. So notice that it no longer involves k. Write an equation equivalent to the equation number 5, regrouping a with sine of a and c with sine of c. So here, I am just going to divide this by c and divide this by a, and we'll do the same thing to both sides. So I'll end up with sine of a over a is equal to sine of c over c. And this is sort of the nice beginning steps of my law of sines. So down here we have another oblique triangle ABC, and I'm going to sketch an altitude from vertex C. So from here to here, and here is my right angle, and again I'll label this K. So we'll go through the same steps. Notice that the two right triangles that are created, one contains angle A and the other contains angle B, and sine of A is going to be K over B. Sine of B is going to be K over A, and here I can get B times sine of A is equal to K, and A times sine of B is also equal to K. And again, we can set these things equal to each other just like we had previously done. So B times sine of A is equal to A times sine of B, and we can regroup. So I end up dividing this by B and dividing this by A, and then multiplying over here. So dividing this also by A and dividing this also by B, what we do to one side, we have to do to the other. So here I end up with sine of A over A, let's make that more of an A, is equal to sine of angle B over B. So I also know from up here that sine of A over A is also equal to sine of C over C. So I'm just going to add this down here, so sine of C over C. This is my law of sines. So sine of angle A over side A is sine of angle B over sine B, which is sine of angle C over side C. This is my law of sines. It is a ratio that we will use sort of as we move forward in solving these problems. And let's do some examples together. So it is a ratio between the angles and their sides. Something really important here, make sure that your calculator is in degree mode. And we'll only use 2 of these sort of pieces at a time. So here, let's say that I have this triangle. So let's go ahead and do a few examples together. Let's say that I have this triangle here that's not a right triangle. We have C, A, and B, little c, and little b. And let's label this angle as 48 degrees. This angle is 36 degrees. And let's call this side length 8. And this is saying let's solve for all the missing angles and all the missing sides. So here is my law of sines. The first thing that I need to do is I need to be able to fill sort of one of these pieces in completely. So I say I want a pair. I want an angle and its side length. So I wouldn't start with B because I have angle B, but I don't have side length B. So B isn't what I want to start with here. I don't have any information yet about C, but knowing what I know about triangles, I know that 36 plus 48 plus the measure of angle C should give me 180 degrees. So this should be 94 degrees. So I will start with sine of A is equal sine of A over A, and that will give me sine of 36 over 8 is equal to, and let's start with B, sine of 48 over side length B. And I can go ahead and cross multiply here, and I'll sort of do this live time with you. So B times sine of 36 is equal to sine of 48 times 8. So sine of 48 times 8 divided by sine of 36, and that is going to give me, and we'll round to the nearest whole number, that B is equal to 10. So now I know that B is equal to 10, and I can go ahead and use the law of sines again to figure out my last piece. So sine of 36 over 8 is equal to sine of 94 over little c, and we'll cross multiply. C times sine of 36 is equal to 8 times sine of 94. So 8 times sine of 94 divided by sine of 36. That is going to give me that side length C is 13.57, so we'll round that to the nearest whole number of 14. So I now have all of the missing angles and side lengths of this triangle. We use law of sines when we have a triangle and we have a nice pair. So I have either angle A here and side length A. We need something to start with. So there's a homework that's attached here. So I'll have you guys go ahead and go in and do some more of these practice problems. Remember that you're only using sort of 2 of the chunks of this ratio at a time, and good luck.